Welcome Wildcats. Today we're going to be looking at the second part of 1.3. It's going to be the vertical and horizontal dilations and compressions. You guys have seen dilations before in geometry and algebra 1. You probably called them stretches though. So we have stretches and compressions, and then we're also going to talk about reflections today. So yesterday's notes had this slide in it as well, and we talked about all of the different ways that you can change a graph. Yesterday we talked about just the bottom four, the translations. Today we're going to talk about the top six. So the red and green are going to be our reflections, and then the orange and blue are going to be our stretches and compressions. Pay very close attention to where they are and the direction of the inequality signs. So let's go ahead and get straight into it by looking at how we can make these stretches and compressions work for you specifically. So we have, as an example, f of x equals negative 4 times x squared. So just like yesterday, we're going to identify the parent function. The parent function in this case is x squared. And you will hopefully remember from last week that this is what x squared looks like. Just like yesterday where we had an order that we were going to do things, the same is true for today. We're going to start by looking at the vertical dilation, the vertical stretch. And we can see that this is a 4 outside of the parentheses. So because we have our 4 outside, this is going to be a stretch. So we're going to squeeze this graph up by a factor of 4 and just stretch it out. And when we do that, it's going to change the look of our graph from what it is now to this new blue graph. And it just, like I said, squeezes it and stretches it straight up. However, you will notice that we also, in this equation, have a negative out front. And if you revisit that first slide, or the notes that you took on that first slide, you'll see that that is a reflection over the x-axis. So in this case, it's going to go from being up to going straight down. So it's a reflection vertically, or a reflection over the x-axis. So we don't change the dilation because we've already dialed that in. We're just going to flip it straight down. So our final graph looks like that green one. Let's take a look at another example. F of x equals parentheses negative 2x close parentheses squared. So once again, we need to identify our parent function, and I hope you guys can see that our parent function in this case is the exact same one that we were just using. So x squared. First thing we need to do is to graph just the initial parent function. So f of x equals x squared, and we have that. Next, note that our 2 this time is on the inside of our parentheses. That means we are going to have a horizontal, and because that 2 is larger than 1, it's going to be a compression. So we have a horizontal compression, and here's the really weird thing about horizontal compressions or stretches. You're not just going to take the number when you look at the factor. So in this case, our number is 2. You're going to take 1 over the number. So since the number is 2, the factor is 1 over 2, or 1/2. And again, this is a compression, so we're kind of just squeezing it closed. Graph is going to look like this blue one. Finally, you see that we have a negative sign on the inside of the parentheses. Again, revisiting our notes from that previous slide, that tells us that it's a horizontal reflection. So it's going to flip over the y-axis. But if you think about it, the y-axis in this case is our axis of symmetry. So flipping it over it actually does nothing at all. The graph doesn't change. So that negative sign in this case, surprisingly irrelevant. Let's do a quick recap here. So for our stretch and compression, if you have something outside of the parentheses and that number is larger than 1, it's a vertical stretch by a factor of that number. If you have the same thing, but that number is less than 1, it's a vertical compression, so you're going to squeeze it down. And that's still going to be by a factor of A. If instead we move that number to the inside of the parentheses, it's now horizontal. And if it is larger than 1, it's a compression. But again, remember that we're going to say it's 1 over that number. So if your number's 2, your compression is 1 by a factor of 1 over 2. And finally, if you are less than 1, but your number's inside the parentheses, now you're going to have a horizontal stretch. You're going to be pulling it apart. And that's still going to be by a factor of 1 over b. Now guys, this is absolutely vital. You have to remember this part. A vertical stretch is the same thing as a horizontal compression. A vertical compression is the same thing as a horizontal stretch. So if I pull a graph this way, it's the same as squeezing it this way. Keep that in mind. It's very important and is vital to remember. Let's take a look at our reflections. Luckily, these are nice and easy. If you have a negative outside the parentheses, flips it over the x-axis. If you have a negative sign inside the parentheses, flips it over the y-axis. So that's vertical if it's outside the parentheses, and horizontal if it's inside. That is it for vertical and horizontal dilations and compressions, stretches and compressions, as well as reflections. That gives you everything you need to know if you include yesterday's video in order to complete your 1.3 homework assignment on my HRW. So, good luck Wildcats, and have fun.